Hello, I'm Nicolas Weninger. I am the leader of the team that's responsible for the mechanical parts of our project, and today I'm going to show you a bit about our current progress with the 3D model, which we're going to use to export the 3D printing files and to reference our construction with. As you probably already know, our secondary mission involves landing an unmanned ground vehicle on the ground once the CAD has finished its descent, and so we have modelled the entire can with all the electronics, or a model of the electronics inside them. The can is split into two main parts, as you can see on the model. The white parts, as you can see on the top here, is called the landing module, in which we will have the landing module electronics, which will release the unmanned ground vehicle, or the rover as we'll call it, once it hits the ground. It'll be in two large parts on the top and bottom. They're just modelled as four individual parts, as you can see, for ease. So if you take those parts out very quickly, you can see that the can itself forms a part of the structure of the can itself, the rover. So the rover is driven by two large tracks that go around the entire edge of it. On each corner, if you take one of the tracks out, on each corner there are idler rollers on three of these corners. Idler rollers. One of them has been moved just so you can see how the roller fits onto the structure with a pin that goes through. At the back of the rover, at the bottom right hand corner, if you're looking from the side, there is a larger wheel. This larger wheel is connected to the highly geared motors, which drive the tracks and therefore the rover around the location. As you can see, this black disc at the front is also the camera module, which has been recessed into the structure to allow for the tracks to go around it very easily. I'll now remove the one of the sides of the can, the rover, to show you how all the electronics, the PCBs, fit inside this relatively compact unit. So, as you can see, we have the main batteries, or the batteries, here at the back, just because it's a very big unit and there's a lot of space there. Next to it, the brown PCB, we have that's the power supply PCB, located near the batteries for clear reasons. And above it, we have the blue PCB, which is the MCU PCB. The MCU PCB houses an Arduino microprocessor and a motor driver chip, which drive, of course, the motors near the back. If we just take the wheel out, the motors are located there. The MCU PCB communicates with the red PCB on the top here, which is also connected to the gumsticks. The gumsticks is our main control processor, which is located on top of the CPU PCB because it makes electronics a bit simpler. The gumsticks, for example, will send a command to the Arduino on the blue MCU PCB to drive the motors forward, and the MCU and the Arduino on the MCU PCB will do so. Just behind the CPU, as you can see, there's a small green block, which is the GPS module. In front of the can, at the front of the can, there's what's modelled as a camera module, which is with the lens opening at the front of the can so that we can see at the base station what the can is seeing, or where the can is currently located, and that is also wired up to the CPU PCB. So, as you can probably assume, we've also got a series of support structures in our model to support these PCBs as the can is actually driving rover. Looking at the model, you can see these red protrusions from the chassis itself, which are the support structures for the PCBs. The camera module is supported by this support structure there, which also acts as a support structure for the MCU PCB and the power PCB, which is on the bottom of the cam. The batteries are also supported in a small little box of their own, and the CPU and GPS PCBs are located on top, again supported by this structure here. The motors have an interesting support structure. So if I just take away one of the wheels, you can see how the motor is supported, mainly by this center, call it a spine, of the structure. Mainly because we need to have the large open space at the back to allow for the most contact area between the wheels and the tracks. If I just open up this part of the model, you can see more detailed how that works. We have these small protrusions here, which align nicely with the motor structure itself, so that the motor itself doesn't actually rotate whilst it's in the support. You can also see how the idler rollers and the pins that support it are supported here as well. You can also see how this is extruded from the edges of the cam. If you look at the other half as well, half one, which is the front half of the cam, you can also see a bit more clearly how those support structures are built. So you have the camera supports, which are there, which are more detailed there. The MCU PCB and the power PCB supports, which are there. If you noticed on the full model, we also have put the two halves back in, there and there. We also have these holes at the top, which will be the place where we put the bolts and the nuts in to support the two halves together. There's also one located just behind there, which is rather difficult to see. The way the entire structure's got to connect together is these two structures here and these two structures here will be connected, so that they'll slide together lengthways, supported by the bolts and potentially a bit of glue, depending on how we decide to assemble the final model. Another thing we realized whilst we were making this model was that we needed to have a way of moving the batteries, because the batteries need to be recharged, and there's no way of charging them in situ inside the vehicle because they heat up. They're lithium batteries, I believe. I'm not sure about that. So we have this little, this relatively interesting method device. So here you have this latch. If you just rotate the latch a bit, didn't work out. So rotate the latch, and then you pull out the this cover, which slots in. Which slots in, it can't be modeled at the moment, but slots in with that support there. There's also a bit of you can see just behind there. There's a extrusion there for the lever to go through. So you pull out the hatch, and the batteries just slide out nicely. It's nicely modelled so that the hole is a few millimeters larger than the battery pack itself to make it a bit easier to pull out. But the battery pack just slides out nicely like that. And then we put the hatch back in. And then we just fix that, and then you just rotate that back in place, and then you're done. Thank you for watching. If you have any further questions or comments, please don't hesitate to contact us. You can contact us over our website, which is teamnova.co.uk, or you can like us on Facebook and follow us on Twitter if you want to as well. Also subscribe to our YouTube channel for more updates. Thank you very much.